All right. Hey, guys. So today I'm going to go over section 4.6, the solution stoichiometry and chemical analysis section. Um, so this video, I'm just going to run through the notes. I am going to create other videos to walk through some like practice problems, but I'm going to put them separately just because it would be really long if I kind of put them all together. And that way you can look at those. I'll label those with the type of problem. So you can kind of go and look through and see those as well. All right. So um, it talks about just in general stoichiometry problems like which that we've already done in like Chem 1 and stuff like that. There are two different types of units. There's laboratory units and there's chemical units. Lab units are the macroscopic units that we measure in a lab. So this would be um, uh, like grams, centimeters, seconds, liters, stuff like that. Okay, chemical units are the microscopic units that relate to moles. So these would be like um, moles, the particle labels, so like um, atoms, molecules, formula units, stuff like that. Oops, sorry. Okay. Um, Always convert the lab units into chemical units first. So we always, and we've done this in stoichiometry, we'll take like grams and convert it to moles, right? Stuff like that. Um, Convert volume or molarity into moles using the molarity equation that we learned in the last unit. Molarity equals moles over liters. Okay. Use the stoichiometric coefficients to move between reactants and products. This step requires a balanced chemical equation. All right. So what this is talking about here, stoichiometric coefficients, that's talking about the coefficients from the balanced equation. We use those to convert between reactants and products or between substances, right? And then you would convert the chemical units back into the required laboratory units. Okay, um, this looks funny because it was wrong in the notes. I had to change it. So so convert moles to grams using molar mass, converts moles to molarity or volume, like that kind of stuff. So it's just sort of kind of walking through stoichiometry that we've already done before. Okay. All right, titrations. The common way to determine the concentration of a solution is through titration. We determine the concentration of one substance by allowing it to undergo a specific chemical reaction of known stoichiometry with another substance whose concentration is known, called the standard solution. Okay. Monoprotic acids and bases react with each other in a stoichiometric ratio of 1 to 1. Okay, so down here, they're talking about a chemical equation, hydrochloric acid and sodium hydroxide, making a salt and water, right? We've talked about neutralization reaction before. The ratio is a 1 to 1 between hydrochloric and sodium hydroxide. That's monoprotic, where there's one hydrogen. Okay? That's what it's talking about. All right. So suppose we know the molarity of a sodium hydroxide solution and we want to find the molarity of a hydrochloric acid solution. What do we know? The molarity of the sodium hydroxide, the volume of the hydrochloric. What do we want? The molarity of the hydrochloric. So what do? You take a known volume of the hydrochloric acid solution and measure the number of milliliters, so this, okay. So, actually, hold on. I'm going to pause here for a second. Okay, so I'll show you in a second here why I pause. So the point at which stoichiometrically equivalent quantities of sodium hydroxide and hydrochloric acid are brought together is known as the equivalence point of the titration. Okay, equivalence point is when, like I said, stoichiometrically equivalent quantities of the acid and base are together. So basically, it's where you have equal amounts of the acid and base, and theoretically, it should be kind of neutralized. And what happens is if you know how much in the concentration and how much of one thing you have in there, then based off of it, like when it hits that center point, you know how much of the acid or the base, whichever one you're adding, you have to add. Okay, what does this look like in real life? So if you've ever like tested pool chemistry stuff, like tested different things for pools, like pH or calcium hardness, stuff like that, you've done titrations. I'm going to show you here the idea, like how it works. Okay, so I have let me see if I can get the glare off of it a little bit, maybe. It's almost worse. Hold on, let me change the lights. There we go, that helps. Okay, so in here I just have distilled water right now. Okay, this is an acid base indicator called phenol red. Okay, phenol red tells you if it's acidic or basic. So I'm going to drop some phenol red. Now this doesn't do anything like it doesn't do anything in terms of like making it acidic or basic. It's an indicator. Okay. So you can see it's a little like maybe a little, it's like clear to yellowish. Okay. Now I'm going to take some sodium. Now this is, or not so, I'm going to take sulfuric acid. Okay. It's not hydrochloric, like the thing over there is, but sulfuric. And I'm going to put in, actually, hold on. Okay, so I changed my mind. Because it's the example in the notes, the hydrochloric and the sodium hydroxide, I went and actually found hydrochloric to do this with, because then they're both monoprotic, the monoprotic acid. So I'm going to take the hydrochloric, and I'm going to put in, see if we can do this, 1, 2, 3, 5, 6, 7, 8, 9, 10. Put in 10 drops. Now, mix it in. Okay, you can see the color basically stays the same, right? Okay, now let's put in sodium hydroxide. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you can see a little bit of it there is starting to turn, right? starting to turn pink, but watch what happens when we mix it. Hey, there we go. Okay, turn pink. That's the titration. Now, it's a little weird because they're both 0.1 molar. So let's see. If this works out, it should be about balanced right now because they're monoprotic and it's 1. So if I take the hydrochloric and I put 1 drop in, see what happens. Hey, there you go. So it's clear. Now, let's see what happens if I put 1 drop of sodium hydroxide in. Okay. Yeah. There you go. So that's called the equivalence point. Essentially, what it is, excuse me, is we've got basically about equal amounts of the hydrochloric and the sodium hydroxide in there. So and the phenol red tells you when it changes from acid to base. So it's basic when it's like pink or reddish, it's basic, and it's clear yellowish when it's acidic. So we've hit the equivalence point because just 1 drop either way can turn it. See, just 1 drop of the acid turns it clear yellowish. Just 1 drop of the base should turn it back. Okay, that's the equivalence point, like in real life. Like that's what a titration equivalence point does. So what I could actually do with this now is what you're actually doing with this is if I figure out, so if I start off like this, right, like clear yellowish, basically balanced, maybe. Okay. So if I put in, say, if I put in an unknown number of drops of hydrochloric acid, so I just went, right? If I just put in an unknown number of drops of hydrochloric acid, and you can see it's clear yellowish, right? So I could actually use titration to figure out how much hydrochloric acid is in there and what the molarity is. So what you would do is you would take something of a known molarity and a known substance, sodium hydroxide, sodium hydroxide at 0.1 molar. And then by counting literally drops, you count 1, 2, 3, 4, 5, 6. Ooh, don't do it too fast. 7, 8. And what you're waiting for is it to turn. 9. That was 19. You can see it's getting close because it's turning, but it's not staying. There we go, 23. So by knowing that I had 23 drops of this sodium hydroxide, I could actually figure out what my hydrochloric acid, like how many drops I need. I put of the hydrochloric in there and what the molarity of the hydrochloric is. Okay, actually, If you look, maybe it's 24 because it just went back. Nope, I dumped it all out here. All right, so that is the idea of the titrations. Okay, now, how does this work on paper? Well, to go back to this, you take a known volume of one, like so here, known volume of the hydrochloric acid solution. So for example, 20 milliliters. And measure the number of milliliters of a 0.1 molar sodium hydroxide solution. So you'd have to know the molarity of the sodium hydroxide and the volume of the hydrochloric. And you could get the molarity of the hydrochloric because you would know the volume of the hydrochloric you put in and the molarity of the sodium hydroxide. Okay. All right. I'm going to do a practice problem. The stuff that they have here is good. The acid base indicator, like phenol red is an acid base indicator. They change color at the end point of the titration. So in titration, we use an acid base indicator. That's like something like this. It indicates if it's acid or base. Okay. And at the end point of the titration, in other words, when they've hit the equivalence point, that's when it changes color. Okay. So that's basically it for like explaining the concept of it. I'm going to do some examples that actually shows you how this works with the actual problems. All right. In some other videos.